Welcome back to D-Tech. Tonight's project is going to be this Mercedes here. It's a 2013 ML350. It is the naturally aspirated, so it does not have any turbos. And the customer's complaint is check engine light, extended cranking, and some rattle noise during startup. Now, all those symptoms, as we all know, are very common issues that do occur on a lot of these Mercedes with the actually both the 6-cylinder and the 8-cylinder. The extended crank is usually a timing related issue where most of the time it's not an actual chain, but the phaser wheels on the camshaft actually tend to shift and it throws the timing off, even though the camshaft core, the shaft, and the lobes are in the correct time position. And as far as like the rattle noise, it's also a common thing that the phasers or actuators or cam gears tend to become faulty and start to rattle up on the startup. So all those issues are not new, and actually not new to the channel. I've done a couple of videos, I believe, on the fixing the issues. One that actually ended up just shifting the wheel back. I'll try to post and or link and share that video, but this one in particular, it has multiple codes for each camshaft, meaning in the past, the situations where I've dealt with the timing code, extended crank, whatnot, the vehicle has had just basically one camshaft code, and on this particular situation, it's got all four cams basically being told that they're at a time, and also a lot of rattling, a lot more than I've heard in the past for an extended period of time after it gets running and so on. So it's a situation I've not been put through before, and so I don't want to kind of just throw an engine or throw camshafts or throw actuator. It's just all over the board, and so I want to try to identify, see what's going on, if this is something fixable or not, or is it better to throw an engine at it, depending on what's going on with the situation. And so what I've decided to come up with is to monitor quite a few things. It was kind of difficult to try to come up with a game plan based on what it's doing and what I want to look at and what I want to try to identify. In the past, when dealing with timing codes, I would scope all four cams and then the crank and an ignition sync and compare it with a known good, or you can tell bank to bank if the intakes do not overlap and they're off from each other, then there is a trigger wheel issue or a timing issue. Again, the same with the exhaust. They're supposed to overlap, but if they don't on the waveform, you've got, again, a trigger wheel issue or a timing chain issue. So that is one way, but doing that takes up 6 channels. The other situation that I've currently got that normally I would say maybe only deal with one phaser rattling at startup, and again we've got multiple codes, and it's a very, very loud rattle at startup, louder than I'm used to. I want to try to identify if we've got one loud phaser, 2, 3, or all 4 making noises. Again, I have the ability to try to capture that on the scope, but we've got 4 phasers. That's 4 channels. So there's no way to do all that with a scope at one time. And I also wanted to add oil pressure, monitor that while cranking, all of this is going on. So the other situation is that it perfectly does it all the time. It's loudest rattle, it's a long extended crank at the first start of the day after sitting overnight or after sitting for 2-3 hours and then you can get it to be loud again. So I want to try to capture all of those things on the first startup of the day when I know it's going to be guaranteed crazy loud, crazy long cranking, so on and so forth. So with that, and I know some of you are just going to jump all over me, but again, I want to capture this all at one time at its first morning crank. So I am using basically two scopes. I've got my Pico 8 channel, and then I've got the Autel 4 channel. And I think I'm going to end up using not all of the 8, but I know all of the 4 and some of the 8. So I want to do all the cam sensors here, and then so that's all 4. That's eaten up, and then the rest I'm going to do here on the Pico with my chassis leads. That with these adapters I can hook up all chassis leads, and then again the rest of the channels, my crank sensor, oil pressure, ignition sync, all that on the Pico. So these are my chassis ears. They are on each bolt of the basically phaser magnet. Here's the other one, and there's the 4th one. So I got those at the face of each cam, and then I've got all my other signals there at the computer. So I'll do this as a first startup, running both scopes, and then I'll look over the data. Go ahead. Crank it up. Shut it off. Alright, so this is the report, and I'll show you all the codes. You saw the first crank that I captured. What I want to do, it's been sitting maybe 3 hours. I'd like to try to get another cold start going, recorded and captured, but I want to delete the trouble codes in the engine computer, see what comes back first right away as far as all the cams, just because there's so many currently present. I'm curious which ones come back first, or what comes back. So before I do the second cold start, let me clear these codes. So again, those are the ones, they're stored. Clear, yes. No faults. Let me cycle the key. And I'm still set up. I've actually added the crank sensor just to have some sort of another reference out of curiosity. Eventually I'd like to get all the cam sensors and crank sensor on one. All right, let's get ready to crank. Alright, so clearly these are the codes that have returned right away after cranking it, after clearing all the codes. It's for both banks intake cams being out, basically. Let's see, yeah, bank 1, bank 2. What I want to do is crank it over again, see if more populate, because not sure if you noticed, but the extended crank was shortened. What I've gone also and done is taken off the noise microphones from the Pico and moved everything to Pico right now. I want to get all cam signals, crank, oil pressure, ignition, all on the Pico 4 right now, as it seems that the cranking time has lessened. So we'll keep cranking and see what what more other codes pop up, if more or when, and if the cranking again does get shorter. So almost right away it starts up, and also I think I want to hold oil pressure at 25, then 35. Let's see. Let's back out, reread right away. Okay, we've got a third one. Another intake one for bank 2. Not sure if you can hear that surging. That's not me with the idle. It's doing it on its own. Let's go to 3500. It looks like this might be having an oiling issue. So that surging you heard was coincides with the oil pressure waveform. Guys, so here is the capture of the first startup, and wanted to just kind of go over and see what we have captured. As far as the channels go, the big, let's call it blob, solid areas here in the 4 channels, these are the noise that we captured. The higher the voltage amplitude, let's call it, and more repetitive is means you're capturing louder noise and more continuous. So I'll explain here in a little bit, but think the more important thing, and so I'll move some of these out the way, and you can already tell right there towards the bottom, the purple channel, that guy there is for the oil pressure reading that we captured during cranking. So let's try to figure out. So, and then this bottom blue one, let's call it, this is our ignition sync. So if we zoom in down here at the bottom, we clearly see a pattern going on. Now, our first crank up point was right here. That's when we started cranking the engine, and when we actually fired and started creating faster revolutions was right here when we started to add ignition. That's when the computer found itself via with it being off time or having timing codes, it's just not happy, so it doesn't crank right away. And this is the point that it finds itself and can start running the engine. Oil pressure, I think the more important thing out of this whole waveform, during cranking doesn't appear to raise up much. After we started running and spinning the engine faster, it does come up, and then eventually it shoots up to a certain level and it looks like it even starts to dive off. Just for some numbers, because it's just interesting. So let's see, the number we reach when we finally start the engine, we are only about 1 psi. That's with the engine running. And then let's see what it shoots up to. Only about 15.5 psi. Now, I'm pretty sure this is not the way the oil is supposed to act. I don't see it being at 1 psi after the engine's running and then shooting off. Let's get actually some time measurement. We can do from when we first cranked it, just to get a number of, let's say, how long it took for the pressure to start shooting up. We'll pick this point there. So from there to there, we are about 6.5 seconds that the engine was living with about a pound and a half. That's after it's even running. Now, if we look at this, let's change the layout. So you can tell loud noise, loud noise, loud noise, loud noise, and all of those drop off right when our oil pressure is at our current highest point. So we're getting phaser rattle noises being the loudest when we have no oil pressure when the engine starts, and then the noises go away once we build up oil pressure. And quickly, just to show you, this is a second cold start. This was after the last capture you saw, but then I let it sit for about 3 hours and perform the same exact test. Again, we can tell when we first ran the engine, because the noise got loud from all the phasers, you can tell our pressure rose up a little bit. Let's get a number, and then you can tell it takes a while to ramp up, and then it ramps up all on its own at idle, and it dipped. So let's see, so we were at about 2 psi, goes to 31 this time, but then it drops off. This is again a second cold start, and the noise, if you look at the green, is very wide, and then it tapers off as the oil pressure goes up. So the same thing has been captured. This is what seems to be going on with the cold start rattling. We seem to have some sort of lack of oiling, and our oiling is what seems to cure that noise. And lastly here, I just want to bring this capture up. Now, if you remember in the video I was capturing, that I mentioned something about the engine fluctuating as I tried to hold it at 2500, and it wasn't from me and the throttle, but it was on its own, and it seemed to coincide with the oil pressure. That's because I could see on the screen that the oil pressure channel was basically doing the same thing that the noise was. If we look down here, and we'll zoom in, obviously the more bunched up is the louder raised RPM, but we can tell down here also with our ignition as far as when we raised it. So let's look down there. Again, clearly you can tell that most likely probably isn't and shouldn't be normal or happening. The purple is fluctuating up and down as we increase our RPM. Here's our ignition a little bit spaced. When it gets closer, more together, that means it's occurring faster, more repetitive because we raise our RPM. And that is, look at our oil pressure. It's not maintaining or controlling. It's obviously fluctuating. And with the fluctuating pressure, physical pressure reading, we were getting an audible change and fluctuation of engine RPM while it was supposed to be maintained at 2500. Now, if we know we were at 2500, let's see what kind of numbers we get as far as pressure. We should go towards the average. So it was having trouble maintaining 26 psi. Now let's just, for giggles or numbers, let's see where our dips go from down to what. So it would shoot up and lose pressure, go down to 20. So we go from 32 to 20. So we were having a 12.5 psi engine oil pressure fluctuation issue, or loss of control, or not maintainable pressure. Alright guys, so after scoping what we've scoped and seeing what we saw, again we're considering thinking about oil issue, oil pressure, something. Because of that, decided to do a quick simple check as basically a basic starting point. And let's see if we can catch it. The oil is down there, basically at its minimum point and below. So I think before getting too crazy and getting all whatever, I'd ideally like to do an oil change, get the right oil in there. Who knows what's in there? But before I do that, I think I'm gonna fill it up with some oil, get it up to a higher level amount, run the same startup test with monitoring the noise and watching oil pressure and seeing if we can get rid of that rattle noise and the fluctuation that occurs at about 2500 RPM. It's all based off oil related, and currently at the moment we do not have a good amount of oil, so let's start with that. Alright, so I've topped it off with some oil. Not sure if that's coming through, but it's all the way up. And I'm just going to test the microphones. Here's bank 2, and then bank 1. Alright, those are working, reading. Let's stop it. I guess we'll go ahead and start it. But definitely a whole lot quieter, for sure. I cleared the codes. Obviously, that first crank up after putting oil in it was still not like true valid because it was still from not having oil. Let's see. So we do have an intake bank 2. Comes back right away. Let's see about the noise. All right, so now we're getting a little bit more of to the normal situations that I'm used to, with no rattle at startup, but yes, extended due to the timing codes where it'll take a while to find itself and then finally run. Once it's running, it seems to run okay. And no engine fluctuation sounds. Wow, from an oiling issue. This is just crazy. To almost condemn an engine or phasers from rattling, just from basically poor maintenance, low oil. Let's reread this. Actually, let me do one more crank up. All right, no rattling noise. So continuously right now, we're only getting the one bank. Which, again, yeah, I mean, phasers are oil dependent, and before, if we didn't have enough oil for all four of them and everything else in the engine, I can see why we would have multiple timing codes as well, because that's how it'll home in a target, is by phasing the gears. All right, so it's still running. I did a couple revs. Let's back out and reread it. Alright, so it's switching between current and stored, and then current, stored, whatever. So I think the more important thing is we're only getting one camshaft code as opposed to all four. So let's see, intake for bank 2. So let's shut it down and take a look. Alright, and so what we have here now is a capture of the same cold start situation, but now with the correct oil. Waveform looks a little bit different. Let's go ahead and move the crank sensor down towards the bottom. Now we still have an extended crank situation because we still have timing codes issue going on, but we're trying to break this down in different parts to try to figure out exactly what's going on. This point here is when we first cranked it, and you can tell because our RPM, or our crank sensor signal, started generating a signal. That means our crankshaft was spinning from the starter, but we don't fire ignition up to this point. But even then, compared to the last time when we were just cranking, we are actually building oil pressure as we're just cranking. Naturally, when we raise our RPM, that oil pressure just shoots up, and definitely different than before when we had basically no oil in there. So we build up pressure just from cranking, and it shoots up naturally because we sped up the crankshaft a whole bunch, and so our oil pump now can create and raise and shoot up the pressure almost instantaneously, as opposed to before it would just took 6.5 seconds to raise it. So this shoots up, and then it keeps raising, and it looks like it maintains right there. Let's get some numbers just to be able to tell the difference. So at the highest we reach when just cranking, and then let's look at where it shoots up to. So we're at 6 psi just cranking. It shoots up to almost 14 initially after RPM goes up, and then after it looks like it maintains, it goes up to 30 psi and holds it. So a big difference in the oil pressure, the way it acts. Our noise levels do seem to go away for sure. It's not as extended and held long, and not such a drastic drop of amplitude. It's more of a, I'm gonna say, subtle. Yes, these two guys sort of stand out louder than the other two, but it's not a whole high amplitude maxed out and for an exact point that we maintain the noise and then drops off because we gain oil pressure. No, it was more of a, let's call it a subtle-ish look that we have, and audibly it is way quieter and way different. Now I just wanted to bring this one up so that we can have a comparison. This is with the correct oil level and with raising the RPM and holding it first at 2500, then at 3500. But if you remember, 2500 was the point where we would have that fluctuation. So let's take a look and see what our oil pressure does. And this is right after the startup, which you can tell again, our oil startup waveform looked way different. And then obviously you can already tell that we have a way different oil pressure reading. So let's see, let's go this way. So again, first of all, our pressure shoots up right away with RPM, and then it goes up, maintains. This is where we start to rev up and hold at 25. So it does shoot up a little bit and it maintains 3500. We get a good quick shot where it shoots up and comes down. I do believe this does have an oil control solenoid type of system, so possibly why we're seeing it look the way that it looks. So there at 2500, it actually shoots up 27 and maintains right about 26. And then no fluctuations is the bigger factor and change, let's call it. And just out of curiosity, let's see what it shoots up to. So about 43, and then it maybe solenoid comes in and tries to control, since it is just revving up at idle. So just wanted to quickly show and bring that up, that also with the correct oil level amount, not only do we rectify and fix this starting point oiling pressure issue, but we also fix the fluctuation issue that we were having beforehand. And so now that we've got our, let's call it, oiling issue situation, rattle noise, pretty much identified and sort of rectified, I wanted to now, after the correct oil level, check the cam sensors and match them up. So this waveform here, it's after the oil top off and I'm watching all the cam sensors. I do still have oil pressure reading, which it's this guy here that shoots up, but let's take a look. We'll zoom in right here in the beginning when it's just cranking. And just like before with the Autel, the top two are our intakes. They're supposed to overlap. The bottom are the exhaust. Those two seem to overlap correctly, especially compared to how the intake looks. So clearly we have this one is intake bank 2. It seems to be advanced from intake bank 1, and it's not overlapping correctly. And we can look at startup idling. And again, same story. Hopefully it is coming out, but it's still advanced continuously as it was when cranking. And this one I think is at 2500. Let's just look quickly to compare, but what we are seeing looks to be that we are having a constant trigger wheel issue. They're not overlapping correctly, or as best as probably they should. As you can tell, the red is still advanced. So looks like we are going to have to deal with an actual just one cam timing problem, just as I normally would get these in the shop when they get an extended crank. And so we'll have to move on and take care of that issue. Alright, so I've got it all put back together. I am going to go just into the engine control unit, clear the code, and I'm going to crank it over. I've got all the coils unplugged. After timing or heads or engines, I like to just crank it over for a while, build up some oil pressure, and just make sure everything is good. So, alright, let's clear the code. Escape cycle key, and again it's going to be just a bunch of cranking. Alright, I'll plug the coils back in and see what it does. Yeah, it's starting to ride up. No extended crank. I think that I didn't even realize that's the biggest thing there. So I'm gonna let it run, warm up. Clearly, I'm gonna have codes for the coils. After it warms up a little, I'll reset everything. You do have to reset the the timing learning in the computer, so I'll have to do that as well. But I need to get the battery charged up a little bit and go from there. So I'm just gonna let it run and warm up. Alright guys, just quickly show you and finish this one off. I've personally driven it about 72 miles just to make sure everything is good, and no more timing code, so we'll go ahead, we'll start it up. No more extended crank. So there you go. Like I said, found the problem, narrowed it down to a specific issue, and that was the fix for the extended crank. And then obviously your engines, all of these are dependent upon the correct oil and the correct amount of oil. So hope this helps. Hope some of you guys out there searching for this issue and cause, that this is useful, and thank you for watching.